This is sulfur dioxide. Where do we start from? I'd like to get from you someone to
value. We calculate the valence of the compound.
Very good. So you can tell us what's the valence electron of sulfur?
Six.
Is 6. That's good. And then oxygen, I think we know all of us now. We said the oxygen has got 6, but we've got how many electrons? Atoms. We've got 2 of them. So what is the total valence electron here?
18.
18.
To give us 18 electrons. So where do we start from? We're going to draw sulfur, the oxygen, and oxygen here. So from here, can someone tell us, explain to us how we can proceed from here?
We draw a bonded pair.
Very good. So we connect to. Okay. So there will be, you can do
oxygen.
Yes. So we can do the counting together. So this will be a 2, a 4. But I've got 89. So the remaining ones we give the surrounding, right? So there will be a 5, 6, 7, 8,
9,
10, right? 11, 12, 13, 14, 15, 16. The remaining 2, what do we do with them?
We give to the central atom.
We give to the central atom. So once we give the central atom, you just check if it is stable or not. So let's check how many electrons do we have here.
8.
I've got 8. That's good. And then in the middle, how many electrons do we have in the middle?
6.
6, not balanced. So it means you have to balance it. Okay. And then the other one at the end, how many electrons are we able to see here?
8.
It's 8. Very good. So how can we balance the sulfur in the middle? Can someone tell us how best we can balance the sulfur in the middle here?
By using rule number 7.
Okay. By using rule number 7,
Yes.
You can get any lone pair. So if you want, you can get this one, any. So that lone pair, it will form a double bond here. So once it forms a double bond, you're going to rub that. You rub that lone pair that you have used. So let's check if there are 8 now. So how many do we have here?
8.
It's 8, okay. And then in the middle here, let's check how many do we have in the middle?
8.
It's 8 also. And then also the last one here, how many do we have here?
8.
It's 8. That's very good. So it means this is the structure. Please, the lone pair, you can get any. I'm not saying you should get from the left-hand side or right-hand side. You can get any side as long as it has balanced the octet rule of 8. That's the most important thing. Okay. So structure number E, is there anyone who's missed a point? I think now you're ready to do some structures on your own, and then we're just going to check them. Anyone who has missed a point from these which we have done? Are we comfortable of us with we can do now some exercise on our own?
Yes.
Mr. Mutambo on your side, Sylvia, Isaac.
Clear, sir.
Oh, okay. All right. If it's clear earlier, I hope you have followed through also, Madam Jessie. It's time for exercise now, using the rules. So exercise.
So I'm having a network problem.
Oh, okay.
So if you can just kindly tell me what you are doing, I would highly appreciate.
Oh, we have done a number of examples. I hope you.
Only one. I'll pick it up.
Only one. I don't know if you were. Did you join by the time of doing this example? Is it Madam Rosemary?
Yeah. Yes, the sulfur oxide. That's why I found it.
Oh, that's why you joined. That's when you joined on this one.
Yes.
On the F. So let's look at the phosphorus trioxide. This is phosphorus trioxide I. So we're going to draw the structure of phosphorus trioxide, the Lewis structure. So let's check together what is the valence electron of phosphorus. So I want you to check the valence electron of phosphorus for the sake of the valence electron of phosphorus
5.
is 5. That's good. Plus the valence electron of chlorine. Chlorine has got how many electrons in outer motion? It is 7. But how many atoms of chlorine do we have? We have got 3. So you find the total. What is the total here?
26.
The total is 26. That's very correct. 26 electrons. So, Madam Rosemary, what you have said here, we are going to write the phosphorus in the middle. I've got chlorine. I've got chlorine. I've got chlorine. So we normally use the bonded pair. So the bonded pair is a straight line, so which represents 2 electrons. So this will be 2, a 4, a 6. But I've got 26 electrons. So you start distributing. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now, I have used 24 electrons, but I have 26. So the remaining 2 you give to the central atom. You give to the central atom here. So once you give to the central atom, you just check. Do you have 8 electrons here? Let's check. Do we have 8 electrons there?
Yes.
Do you have 8 electrons on the first one?
Yes,
Yes,
sir.
sir.
Yes.
Are we able to see? I've got 8 on the, and then here, how many electrons we
Yes.
have? The other chlorine. Okay.
We have
8.
8.
8, and then this one, how many electrons do we have?
8.
8.
8. And then the one in the middle, the phosphorus in the middle, how many electrons do we have also?
8.
We have 8.
It means you are done. So ideally, you distribute the electrons and you make sure that the octet rule has been followed. That's the most important thing. Okay, you make sure that the octet rule has been followed here. Okay, is it fine now so that we can do the exercise now, Madam Rosemary? It's okay.
Thank you.
All right. So allow us to do some exercise now. Like I mentioned, I wanted you to try now on your own exercise here. Okay, so the first one, you're going to try the A. You're going to try the ozone. This is it, the oxygen trioxide in short, or that's the ozone, the O3. The B, I would like you to try sulfur trioxide. The C, I would like you to try, this is just, let me give you methane, CH4. And then the D, you can try, which one can we try here? I think we can try, okay, I think you can try, okay, I think I'll be very happy, but we can, maybe the D will try it together, it's okay. This is 5 for alcohol. This is the alcohol, which is the CH5OH. Don't worry, this one will try it together, but just do the A, the B, and the C. The A, B, and the C only, they will do for us. Please just give it a try. Let's see the answer we're going to get, the structures, the 3. So we can give it a try, okay? Is it fine? We can give it a try, these structures.
Yes.
Yes, sir.
All right. So so just leave out the D. The D, we'll do it together. So just try to do A, B, the C. Once you reach on C, let me know. We do the D together, and then we're going to proceed from E and F. Michelle, I hope you are following through. Michelle, are you following through what you're doing?
I am.
Okay. Kasongo, if I hope you have logged in as well, and I hope you are following through as well. And Anita as well. I hope you are following through. Carol, on your side, are you following through? Okay. How is it going?
So far, so good.
Okay. Okay, we are on number what? Those are done. Is it possible I can get some structures from you? Those who are done. Those who are done, are you able to give me some structures which you have? Those who are done with A. Is there anyone who's done with A?
Yes, sir.
Right, please you can proceed. How many electrons did you get?
18 electrons.
Okay. And then you can describe for us how your structure is looking like, the one you have drawn.
Oxygen. Oxygen, 3 oxygens, yes. Then what's this bond?
The bonded pair.
Bonded pair.
So 2, 4.
2 bonded pair, 4, yes. Then I distributed the remaining electrons.
So okay, so you distributed all of them. So this is like this.
Yes,
is it
then
correct?
I remained with 2.
Yes, remained with a
Then,
2.
Yes. Then I gave to the central
Atom.
atom.
That's correct.
Yes.
And then the central
Then
atom
I
is not
checked
balanced.
the balance.
Okay.
It's not balanced, so I got the lone pair from one of the oxygen and made a double bond.
Yes, very correct. And then it has balanced now. Why? Yes, that's very correct.
Yes.
Other colleagues, just confirm if you have got the same structure. There's a double bond, yes, which is very true. There's a double bond between an oxygen and oxygen.
I have a question.
Please proceed.
I've also found that, but the way I've drawn it is different. So we're supposed to do this the way you've done it?
No. You can write it in whatever format. It doesn't matter, whatever format of your choice. But what's important is it has to come out. It has to be a balanced structure. I'm not saying I should put my oxygen the way I've put them like this. You can put in whatever. It's up to you.
All right.
Someone to give us the B. Those who have done with the B. Those who are done with the B. The sulfur trioxide.
Yes, the valency I found 24.
The valence electron is just 24.
Yes.
And then so you can describe for us how is the structure looking like?
Sulfur as the central atom, then oxygens. Yes, like that. Then the
bonded pair. Okay. So that's
6, then distributed the rest.
And then you distributed the rest?
Yes.
So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Isn't that so?
Yes.
Yes.
And then you have gotten any lone pair, right? So you can get any, please. If I want, I can get there. Okay. So are we comfortable? This is the structure that we have?
Yes, sir.
Yes, sir.
And 8.
Yes, sir.
Number C, can I get it from also Mr. Mtamba? Are you able to give us number C on your side? The methane. the methane.
No, that one I didn't finish it up, sir.
Oh, okay, so okay. Anyone else finish? You can have sisters. There's no problem.
So the valency is 8.
The valence is 8. That's correct.
Then carbon as a central atom.
Mm-hmm.
Then hydrogen, all the 4 hydrogens.
Okay, that's correct.
With the bonded.
Yeah. So 1,
2.
So this is 2, 4,
4,
6,
6,
So it's
8.
balanced.
and it's balanced already. Yes.
Yes.
So Mr. Mtambo, are you comfortable also with that? And other colleagues, are you comfortable that this is how the methane structure will come out?
Yes, sir.
Yes, sir.
Now, number D, I said we're going to do it together. So please make sure you participate. So let's start with Sylvia. Where do we start from? Drawing number D. Where do we start from? So I'd like you to explain for us. Where do we start from?
I think the first thing we start with is calculating the valency for the compound.
So you can tell us which one. You can tell us, yes, this one, the carbon.
Carbon, that's 6.
Not 4. The valence electron.
4, yes.
Okay, and then the next one.
That's 1 times 5.
Times 5. That's correct.
Plus a 6.
For oxygen. And then plus what?
1.
A 1 for
hydrogen. So the total we have how many?
16.
So the total I've got 16 electrons. That's very good. So now we are going to draw the structure. So so you have seen it's very difficult for me to know. By the way, in case you're wondering how do we know which one is in the central atom? The one which has got the less number of atoms is the one which is in the central. Okay, so there will be a carbon surrounded by, there's a number of hydrogens. There's a number of hydrogens. Okay, and then as you can see, there's oxygen. And then there's also, how many hydrogens do we have? We have got 6 of them, isn't it so?
Yes.
We have got 6 hydrogens. We have got how many hydrogens? There are 6. Okay, there are 6. So let's do the connection now. So I've got 2, 4, 6. This is 8, 10. Sorry, it's supposed to be, I'll explain something here. So 2, 4, 6, it's supposed to be this. Okay, so let's see how many hydrogens have I written. Are they 6?
They are 5.
They are 5.
They are 5. They are 5. Okay, so meaning there's supposed to be another one here. There's supposed to be another one here. So let's check. Have we counted? This is 2, 4, 6, 8, 10, 12, 14, right? Okay, we have got 14 here. So we're remaining with how many electrons there?
2 or 4. 42.
We're remaining with 4.
2.
Sorry. This structure of alcohol, sorry, there's supposed to be a 2 here, is C2H5OH. Sorry, they're supposed to have 2 carbons. Sorry, just take note of that. I'll rub it again. We're supposed to have 2 carbons. It's the structure of alcohol. So we are supposed to multiply the 4 by 2. Just take note of that. Sorry, we're supposed to have a 4 you multiply by 2. So what will be the total valence electron here? Sorry. So it will be, you can just calculate for me once more. So this is 8, 13. I don't have 20. Is not 20?
Yes, 20.
Yeah. So we're supposed to have 2 carbons. Sorry. So it's supposed to be carbon. There's also another carbon. And then there's oxygen. And then there's hydrogen. Yes. So let's put the 5 hydrogens. So there'll be 5 hydrogens. 5 hydrogens. So these are 1, 2, 3, 4. They're 5. Yes. So 1, 2, 3, 4, 5, and then there's also, oh, there are 6, yes. So let's connect them. So this is a 2, a 4, 6, 8, 10, 12, 14, 16. So remember, I'm remaining with how many? I've used 16. How many are we remaining with?
4.
So where are we going to put the 4? We are going to put the 4 where it is not balanced. Can someone identify for us where this structure is not balanced?
The oxygen.
The oxygen. So this is where you're going to put the 4. This is where the 4 will be, which is very true. So once I put those 4, it has balanced here in the middle. So this is the structure of alcohol, the methanol. Okay. Are we comfortable of us with the way we've done the structure here, just in case maybe I've missed a point? Anyone has missed a point here, this structure?
Sir,
Please proceed.
is the last hydrogen balanced?
Oh, hydrogen, remember, Mr. Mutambo, hydrogen exception. It doesn't need any electrons. It's already balanced on its own.
Okay.
It's stable.
Yeah.
Mhm.
Yeah.
It's okay. Right. So
Yes, sir.
try the last one, and then we are done, so that you can start your biology. So I'd like you to try the E and the F. Just the two, the E and the F. Those are the last one, and then we are done. Please, you're just trying the E, which is the nitrogen dioxide, and then the F, you're going to try the hydrochloric acid, this HCl, just the two.
Nitrogen. 5 times 2 is what? 10.
You're making noise.
So
Your timetable. The physical biology, what time is this showing? It's 12, right? Okay, so I think we'll do this because I'm done. What we'll do is here, this, okay. This is 11. Hey, I mixed the medicine.
the
Okay. You can proceed.
the E, is it going to have a triple bond?
Very correct and very good. You can give us the structure the way it has come out, the E. How many electrons, first and foremost?
10.
It's 10. Okay. And then how have you drawn the structure? How is it looking like?
And nitrogen. Bonded pair to nitrogen. In fact,
there's a triple bond here, right?
Yes, there's a triple bond there. Then 2 there, 2 the other side. Yes, like that.
Yes, that's very correct. That's very good, correct. Please make sure you confirm. But the other one, can someone tell us the other structure also?
The other one, I got the valence electrons to be 8.
Okay. So this is 8. Okay.
Then said chlorine.
Okay.
And then bonded pair.
Okay. So there's a bonded pair.
Then I distributed the remaining electrons to chlorine.
Chlorine. 1, 2. How many of them?
6.
6. Very good. That's very correct. That's very good. Is anyone getting a different answer from them? Is anyone getting a different answer just in case? So are we followed through all of us the procedure?
Yes.
Yeah. So in the group, I've sent the worksheet in the group, the worksheet. That worksheet is for practice. So it has got the boxes. So when you open it, it has got, let me just show you maybe what I've sent you in the group. Exam way test. So let me just open it for you and then you see quickly here, the worksheet. The worksheet here. Okay. Please confirm if you're able to see the worksheet, all of us.
Yes, sir.
Yes.
This worksheet, you'll be drawing the structures in the boxes. So you are going to do on your own for practice sake. Please, group 1, you are going to draw the group 1. Jump the group B. The group B, that's what we're going to do together in the next class. So you do group A, group C, you do group A, group C, group D, group E, group F. So you're just going to remove only the group B only. So please remove group B alone. We're going to do it in the next class. But from A to F, please, you are going to practice those. Okay. So these are just for practice sake, right? So I'll send you the lesson. And of course, I've already sent this in the group. Please, you're going to proceed. You're going to start the biology class in the next 3 minutes at exactly 10:20. Yeah. So we will use we'll use Zoom, the same link which we use. Okay, no problem. I think we use okay, no problem. So in the next 2 minutes, by the way, sorry, you're going to you're going to start your biology class at 10:20. All right, thanks so much. Please make sure you practice a lot. I'll send the lesson to you just now as well.
Thank you, sir.
Are we
Come again?
the one for are we using Zoom or for one for yesterday?
You are going to use the you